So in this video we are going to define and talk about a quick little function that we're going to use later on in some of the triangulation videos. And what the function is called the function is called left in my computational geometry textbook. But what it does is it tells us if a point is left of two other points. So if we have 3 points, let's see, A, B, and then let's call this one C. Just, not a surprise or anything, but we're gonna call that one C. And what the function will do is it'll tell us if we draw a line between, if we draw a line between A and B, is point C left of that line or right of that line? And the function itself is not very hard to write, and I'm going to explain why it's not hard to write. But before I do, I need to preface that this video relies on the previous video I did on the area of a triangle. Basically, the function I'm going to write in C code will use that function we defined in that video. So if you haven't watched that video, go back, watch it. I tried my best to explain it. It's not too hard, but at the end of the video I actually do show the code, so if you want to, you can just copy that code, and then what I show you here will pretty much flow right into that. Okay, so back to our story. We have these 3 points, A, B, C, and we want to know if C is left of A and B. So the way we do it, to understand it, we have to go back to a little bit of trig and understand that when we have a point, let's draw our A point right here, more or less in the center, and this will be B, and we'll draw a vector between A and B. In trig it says that when we go counterclockwise we're moving positive, and when we go clockwise we're moving negative. So if we take the area between A, B, and C, we should get a positive area. Whereas if we take the area between A, B, and C prime, we'll get a negative area. So I know it's kind of simple, but that's more or less it. So the function is going to be left. I can do a better print than that, I promise. The function will take in 3 vertices, A, B, and C. And then all we're going to do is return area 2, which is from my previous video, A, B, C, greater than, let's say 0. Basically positive. If this evaluates to true, if area ABC comes back with a positive value, we return 1. Otherwise, we return 0. Nice little Boolean function. I can actually show you the code from my program I've been writing as I develop these videos. Let's see, where's my area function here? I'm on my second screen right now, so just give me 1 second. And let's see, it's bring in text. And we'll put it right there. So there you go. There's the function I actually wrote. Is vertex C left of vertices A and B, and it's almost identical. Vertex A, vertex B, vertex C. Area 2, ABC greater than 0. Done. There you go. And that'll tell you if it's left of A, B, or C, or if C is left of A or B. We can extend this. We can extend this into 2 other functions, which will come really in handy when we start doing the triangulation videos, specifically when we start looking into diagonals. And what those other 2 functions are, let's see, let's kill that, let's kill that, and that. And what the other 2 videos are, or what the other 2 functions are, is one is called collinear. Let's see, let's go back to a different color. How about green? So we have collinear, And what collinear is, for those who don't know, is if we have 3 points, A, B, C. And what we want to know is if we have these 3 points, are they in line with each other? Are they perfectly in line? Now, I know you could say, well, you could just check their x or y values and you can see, but what happens if we have something like that? That becomes a little bit harder to check. So what we can do is we can use that that area function again and check to see if the area is 0. If the area is 0, then we don't have a triangle. So obviously all the 3 points are in a line with each other. So we'll, instead of writing the collinear function up, I'm just going to copy and paste it again just because I'm being lazy today. So let's see. Let's do a different color. How about some yellow? Whoops. Didn't mean that. So there's our function, collinear. And again, we take in 3 vertices, A, B, and C. We run it against area 2. Again, same function from the previous video. And if it returns 0, only 0, then we know that all 3 points are directly lined up with each other. They are collinear points. And we get a nice true from the collinear function. Otherwise, we get false. Nice, simple function. The last one is a combination of the two. We're calling it, the book calls it left on. And it's, let's go back here a bit. It's basically this function. The only difference is, ignore this comment because it doesn't make sense for this particular function. The only difference is we're doing that. That's it. And what we're doing is we're basically going to return true if it's collinear or if C is left of A and B. The book uses this in finding in-between values, which we'll get into. Or I'm sorry, not in-between. What does it use it for? Let me go look at my code real quick. It doesn't use it for in-betweens. I think it uses for intersects. No, it uses for, sorry about the long delay there. It uses for determining if a diagonal is inside or interior to a polygon or exterior. We'll get to that much later when I go into other videos. But basically just know that there is a third function which I will reference later on called left on, and it returns true if A, B, and C are either collinear or C is left of A and B. And then again we go back, we have the left function, which is that. It returns true if and only if C is left of the vector between A and B. And then we also have the collinear function, which returns true if and only if A, B, and C are collinear. So you get 2 extremes in the in-between. And I think that's about it for this video. Not much else to explain. As always, if you have any questions, comments, concerns, just hit me up on YouTube or my blog, and I will be happy, or I will at least try to answer them. So, later.